So the first thing we're going to remember about the shift we're making from short run to long run is that the firm is no longer stuck to a single technology. It's not stuck with any fixed cost. It can change its technology. But remember, when technology changes, I have to recalculate everything. Remember, technology was ceteris paribus? It was one of those things that was ceteris paribus, which means that technology was given when I did my marginal cost, marginal productivity curves, marginal and total productivity curves, and then therefore it was fixed when I did my cost curves. And each time I changed my ceteris paribus, I had to change the entire curves. That means in the long run, something very interesting is going to happen. Every time there is a change in my technology, there's going to be a change in my cost curves. Item 1. Item 2, I actually know something about this change because this is no longer returns to productivity, which is what I did for my marginal product and my marginal costs. This is returns to scale. So let me give you an example. If I produced at a small volume, so let us say we're talking about boats versus cars. Let me put it that way. I'm a producer. The technology for boats and the technology for cars in a theoretical sense, not that different, okay? I need a motor, I need metallurgy, I need a seat, I need some place for passengers, I need a driving gear. Theoretically, the engineering tech is not that different. However, when we produce boats, they're way more expensive, and we do very small scale production, and that has to do with the size of the market, as we're going to talk later on this quarter. So if I'm only producing a small amount, as I'm doing with boats, because tons of people are not going around buying personal yachts, I'm going to use a high cost, see that cost curve up there? A technology, maybe more labor intensive, maybe more skilled labor. When I produce more, as I do with cars, I get returns to scale. It's not that boat producers are technologically don't know about metallurgy or things like that. It's just that it doesn't make sense at that scale to produce using a technology that's been developed for mass production. So when I produce at a higher level, mass production, it becomes possible for me to use assembly line to produce cars using large-scale production with more mechanization. If I'm producing computers, I can do this at even more massive scale. So you can begin to see that, for example, if I'm taking computers, if I wanted some really high specialist computer equipment for a research lab, I might need to pay more because it's not mass produced and I'll need to do some specialty tech for that. But if you're producing tons of computers, Android phones, iPads, whatever, scale allows you to choose a technology which is cheaper. So the change in technology reflects what is called returns to scale, the scale of production. And so depending on the scale, I will have a different cost curve that makes more sense. What I can do is to use this knowledge to say, okay, if I was producing at this level, I might have wanted to produce here, but that's actually not as useful. I should produce there. Yeah, can you see what I've done? I took the lowest possible point I can reach for a particular quantity, on a cost curve, which means that depending on the quantity, I chose the technology that worked best for that scale, lowest for that scale. And for each quantity, I can do that. And this, it's sometimes called the envelope theorem, because it's like an envelope. Can you see? It's like the bottom envelope of all my short-run cost curves. And that's my long-run cost curve. Each point on the long-run cost curve reflects a different technology and a different underlying short-run cost curve. So in the short run, I might be stuck here, but in the long run, I might be able to switch to a different technology and get to one of these different ones. What can I say about the shape of this? Why is it U-shaped? Now, it's not because of marginal productivity, because remember, that is a short-run concept. The idea is scale, increasing, decreasing, constant returns to scale. There is a point at which when I expand the scale of my production, instead of producing a teeny number of boats, I now go to mass scale. I can benefit technologically by being able to use techniques that are for mass production. Think electrification, think cars, think computers, big production. Eventually, however, I can't really, because I'm a single firm, there's a point at which I can't, unless I'm a monopoly, in which we'll come to this whole case of natural monopolies later. But eventually, if I keep on trying to produce at a bigger and bigger and bigger scale, I have to manage more shops, I have to produce across 15 countries, I have to do this, I have to do that. I just cannot benefit that much by my scale expansion, right? So this is increasing returns to scale. My costs are going down, I'm benefiting from scale. Then eventually I will end up with decreasing returns to scale. That once I hit a certain point, I can't just keep on making my firm bigger and bigger and bigger unless I'm a monopoly. I'm going to hit a limit. And then costs will go up even if I keep trying to move to bigger tech. So here, returns to scale is a long-run concept. It's the idea that the firm will choose the technology on this long-run average cost curve that corresponds to the best technology and cheapest way to produce for that volume of production, for that scale. And so corresponding to that, I have a long-run marginal cost curve. But remember, that cost curve is based on the capacity to actually switch technologies, not just increasing or decreasing production from a single 1 or 2 units with fixed costs.